Hello, this is the fifth video of the third complex numbers series for OCR Pure Core AS Further Mathematics, and it covers modulus definitions for loci. Consider the loci modulus of z minus z1 equal to r, with a fixed point z1 equals x1 plus iy1 and variable point z equals x plus iy. We want to find the set of points that the variable point z equals x plus iy could possibly occupy. A locus is the set of locations or points that conform to a given rule or set of rules, and the plural of locus is loci. So let's think about what a fixed point and a fixed length, for example someone with a conker on a piece of string, or someone with a sparkler, and think about all the locations that the conker or the sparkler light might be in if we whirled around the string at full stretch, or the sparkler with an outstretched arm. Think if you imagine this, you can see that we would get a circular trail. We can show this mathematically by considering z minus z1, which would equal x minus x1 plus I y minus y1. Thus the modulus z minus z1 equals the square root of those elements x minus x1 squared plus y minus y1 squared, and this will equal r. Hence, if we square both sides, we will see that we get an equation of the form x minus x1 squared plus y minus y1 squared equals r squared, which is of course the equation for a circle with centre x1, y1 and radius r. In this Argand diagram, you can see that an arc portion of that circumference of that circle has been drawn. Let's consider this example. To find a set of points for which the modulus of z minus 3 minus 4i equals 5, we would first rewrite the modulus as being z minus brackets 3 plus 4i close brackets equals 5. That then decides what z1 is, in this case 3 plus 4i. The equation now represents a fixed distance of 5 from the variable point z to the point 3, 4 on the Argand diagram, and we know that this will give us a loci of circle centre 3, 4, radius 5. So, looking at the circle on the Argand diagram, what we are saying is that the variable point z equals x plus iy can be anywhere on the circumference of that circle. Now let us consider loci of the form modulus z minus z1 equals modulus of z minus z2. Here both z1 and z2 are fixed points. And what the equation is saying is that the distance of the variable point z, which we want to find, from to z1 is the same as the distance of that variable point to z2. What that distance is can vary. On the Argand diagram here, we're showing a variable point z equals x plus iy as just one example of the loci that meets this equation. There are an infinite number of other points x, y that would obey the rules, and the locus is therefore the perpendicular bisector of a line joining z1 and z2. Only a segment of that perpendicular bisector is shown on the Argand diagram in red. Considering this example, the modulus of z minus 3 equals the modulus of z plus 3 minus 4i. We would initially rewrite this. Z minus, and we're going to think of this as being 3 plus 0i. Just to be clear that that 3 is still a complex number, equal to the modulus of z minus 3 plus 4i. And this allows us to identify the two fixed points. So we can say z1 is just 3, or if we want to, 3 plus 0i, and z2 will therefore equal minus 3 plus 4i. Those 2 points are shown on the Argand diagram here, and we are trying to find the set of points variable points z equal to x plus yi, which are equidistant from those 2 points. We know the result will be a perpendicular bisector of a points 3, 0 and minus 3, 4. We can also work out the equation of this line. We know our variable point z equals x plus iy, and if we substitute this into the modulus and remove the modulus by squaring both sides, by doing some algebra and cancelling out the x squared plus y squared from each side of the resulting equation, it reduces to minus 6x plus 9 equals 6x plus 9 minus 8y plus 16. We can rearrange this then in the form that we're used to for a straight line, y equals mx plus c, and this results in y equals 3 over 2x plus 2 being the equation of the line. You may want to pause the video here and check all this working for yourselves. In the next session 3.6, we will be covering argument definitions for loci.